Joyce, at the beginning of class, hi Joyce, at the beginning of class, I let them write down whatever rules they wanted from this page, because some of them, like, let's see, I think this one came up in homework, even though there was a way to do it. Besides, there are also some funny ones from last year we probably need to remember and review, because they're not on the tip of our brains. We already talked about arc trig yesterday, those are the main ones, right?
Yeah.
Yeah.
So anyway, Joyce, if you want to write those down, go ahead. You can pause it now. Otherwise, we are zooming back. Or I should say, next they did in notes. They tried to finish this example that we didn't quite get to the end to yesterday. We'll see the solution to that. But they did have 2 questions on odds from last night. So number 21 quick, and then number 49, followed by us checking the evens. 21. All right, cool kids. How do we plug in?
Or did we actually have to solve with the use of?
Let's just peek at how the use sub works. How about that? Does that sound good? Okay, so the use sub, how does it work? We could go ahead and plug in check, except u equals x over 3. Well, if u equals x over 3, they told us that. All right, we'll get back to that. Then we could go ahead and say that du is equal to 1/3 dx, right? So dx is equal to 3 du. We're going to go ahead and plug and check that in just a second. But how do you plug in u? You pull out a 9. So when you pull out a 9, you end up with a +1, but then this is going to be a 1/9 x squared, which could be the same thing as x over 3 quantity squared. Check it. Does it make sense?
No.
Distribute. 9 plugged in, that's going to be x squared over 9. The 9's cancel, and then 9. Oh. So x over 3 is what happens when you factor out the 9 to get to u squared plus 1, which is our original arctangent derivative formula.
I was just confused on how you could plug in u when we don't have, or no, when we just have.
Yeah, if you factor out the 9, then you can go ahead and go u squared plus 1 du times, I guess, 3. That reduces to 1 over 3. That reduces to 1/3. This is the arctangent derivative, so they're trying to make you not have to memorize a new rule. But in essence, I think you guys agree with me that it's easier to do 1 over a arctan u over a. So it's your choice. This one ends up being u, and u ends up being x over 3, which is the same thing as u over a for our formula. So I don't mind you guys using arctangent, but it's not a bad thing to peek at it and see how or where the formula actually comes from, right?
Since it was x squared, wouldn't it be x squared
Over 3 squared, which is 9.
over 9?
Mm-hmm. And bring the 9 in, that's just x squared alone.
Why would you bring the 9 in?
Well, if you're trying to compare and make sure they're the same.
Oh, because you can. Or you can bring
I
it
made
in.
the jump to x over 3 squared and just showed you, hey, do the distribution, you can see it works.
Because you could you can justify it because
It'd be x squared over 9 and then you make it x over 3 squared.
yeah. Okay.
Yeah, good.
All right.
I just didn't want to show you work for that. I was being amazing short because people are going to use the other formula anyway. Number 49. Use the given trig identity to set up a u substitution and evaluate the indefinite.
Oh, that one took me a sec.
Hey, couldn't you just make then this to be cosine of 2x minus 1?
I did 1
Is
minus
that
cosine.
all of that was asked?
Ooh, but that's going to be a negative, sorry.
Okay, so we could do 1 minus cosine.
I think I did something like that.
Yeah, that would have been smarter.
I
Sorry, I didn't notice the sign change, so we could just
I
do
did
1
that.
minus.
And then
Yeah,
just
1
split it
minus.
up.
Yeah, and I split it up. That took me a good while to do.
That was quick.
So the derivative of, or sorry, antiderivative, integral,
So you get,
of 1 is x,
minus
and that's going to be plus, no, minus, because we're going back to sign, right?
minus sine
Minus.
one.
All better. You
Oh wait, no, there's a 2 outside.
Don't they?
Oh no, okay, never mind. I took it out because I
There you
thought move the 2 sin x.
Yeah, you were thinking separate the 2, but you need the 2 in order to go to the property. Struggle, so maybe it might be impossible without trig identities.
You know, it's funny. I was writing plus C. And I was like, plus C. Okay, writing plus.
Oh, you're like, wait, what's going
Then
on?
we had
First even.
6.
Number 6, final answer should be, I'm just going to have you guys see it. Is that cool? Just say done when you're done.
Done.
18.
18.
Okay.
1/4 sine.
Where the hand is.
Yeah, got it right. Dun, 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 dun.
Ooh, this is not the wrong.
What's the next one?
70, I think.
70.
Yeah, I gave you a lot of odds. But I just wanted you to be able to check it. Was that okay?
I didn't know what I did, yeah.
I didn't.
Oh, this
Because
one?
I got ln of the absolute value of sine x plus 6, not sine x over sine.
Oh, this one? I looked at like the answers and I was like, oh, got it. Because it shows you that, so then I just went from there. I was like, okay.
Were you working backwards on this one? You were, right?
Something like that.
Oh! You're supposed to work backwards.
No, I didn't work backwards. I integrated.
I thought it was like the initial value where
Yeah.
you.
Yeah, so you derive, you integrate the derivative. So it's like, you use the fancy like a to x, and then you give you a point. So you put the point is 2, and then you put it's 2, and then it goes 0, and then you have like c.
They were saying is the solution. I don't know if they necessarily told you had to solve for the entire solution, did they?
It says show that, so I was just like,
Yeah.
okay, cool.
So you guys were trying to, my ones who got stuck, you were probably trying to actually solve the problem given to you, but technically they weren't telling you that you had to solve. They just said, show that, hey, show that he actually works, basically. So what they did was go ahead and take the derivative, but don't take the derivative the way it is. Take the derivative, and you're right. The integral of cotangent of x is ln of absolute value of sine of x, but then you have a plus c, and look and see at the work as to why this works, because plus c just means a constant. Couldn't this whole thing be plus c? 6 minus ln of sine 2, but then the sine 2 gets pulled in because of quotient property. So, in theory, go ahead and separate those using the quotient property. This is technically all plus c. You take the derivative, and then you do end up with exactly what you need. And if you plug in 2, you do get 6. Does that make sense?
Yeah.
So you're showing it works instead of solving for it outright. But the reason it works, oh, poor buddy, is because the plus c.
Just Steve?
Yeah.
I did the fancy little trick where you do integral from a to x, and then you use the point as an intuition, put a, and I made the same point x.
And that does work for this one because you end up with an ln of sine a, and then you can plug in and solve. So no, that does work.
Yeah. So like that's what I did, and I was just like, does that take longer? I don't think it takes long. It takes about the same time,
I
right?
don't think it takes longer. I think it's a equivalent or an alternative. It's an alternate way of doing it.
45.
Yeah,
Sure.
45.
Oh, that one took me so long.
Yeah, can you see how you do it?
I kept trying. For some reason, I was in my head. I was like, I need to simplify this. I need to simplify this. Whenever I multiplied it over, but it was just way more simpler than that. Way more
You know
simpler.
those weird hints? I don't like the hints.
Dude, the hint. Once you figure out.
Well, the long story short of it is you could technically use the property we wrote down today, right?
That's why I don't like when they make it feel right.
I know, they make you do it the other way. But they actually gave you that hint though, right?
Yeah.
Okay. So the reason is because they wanted you, there we go, multiply. They told you what to do. They were basically showing you where the solution comes from. So when you multiply, then you can go ahead and let u equal the top part, and then the du is going to work out with what you have. I think it ends up being 1 over u, right?
Yeah, it does.
Yeah. So let u be the denominator, and then when you find the derivative, you end up with the secant squared x plus secant tangent.
When I figured this one out, I had such a euphoric response. It was like, I was so happy. It took me so long, so many erasing marks. I was so frustrated.
So basically, let me go back here. You multiply top and bottom, that was their hint. And when you multiply top and bottom, you get secant squared plus secant tangent, which you notice is the derivative of, and is the derivative of. So this whole thing is just du, this whole thing is u, and the integral of 1 over u du is ln of u. Does that make sense? But yeah, they gave you the weird hint, but that's why I gave it to you, is because I was like, well, it's weird and it's out there, but they tell you what to do, and maybe you'll understand how it works out. But yeah, it was funny, I agree. Was 70 our last one?
Yeah.
Alright. Let's go ahead and get out of here. We made it? We're good? We're okay? Ish? Guess what next section is? Woo! Ooh,
Wait,
this looks
What?
new.
is it? Ain't that a kick in the head?
Right there. He's the big idea of section 7.3. But before we get there, let's go ahead and go back really quickly and make sure that we were able to finish this funny one. Uh-oh, that's not what I wanted. Struggle. Let's try again. Okay. Boop, boop. To complete the square, you take the middle term and you cut it in half, right? And so 3 cut in half. Squared, you end up putting a 9/4 on the inside, which translates to be the opposite on the outside, so negative 9/4. 7, your right is 28/4.
Oh, that's where I messed up.
4, so I end up with, I can pull 7 halves out here, right? I end up with x plus 3 halves quantity squared. Remember, whatever you squared is what the factors will become. Keep the sign of the middle term. 28/4 minus 9/4 would be 19/4, right?
Yeah.
Who is this? Arctan.
Okay.
Wait, are you kidding? U over A? Question, what is your, now, before I get too confused, I'm going to go ahead and change this one out, because this U is a different U, right? This one is, let's see, U is x squared plus 3x plus 7, plus, now if you want to, you could go ahead and technically do a V, so Gerardo, here's one way of thinking about it, because U is for one part, this shouldn't technically be called U, because U already has been established. I could call V x plus 3 halves, I could call A square root of 19 over 2. It's gross but true, right? So I can go ahead and say 7 halves times 1 over A, which would be 2 over rad 19. So it's the reciprocal. Times arctangent, or tangent inverse either way. Oh,
Satan.
it's your new phrase, huh?
Well, Satan is destroying. I don't know.
Does that work?
Just gotta stick to the man or something. Hold up, 1/2.
Or you can,
Oh yeah.
I guess leave that. You can put this 1/2 up and make it a square root. Does that help anything?
No.
I can take away those absolute value bars now, right?
Why?
Isn't the square root always?
It's negative.
What do you mean it's negative?
Negative.
1/2?
Oh my gosh, I'm dumb. There was an accidental, like I was moving my pen and I accidentally marked my page. So
Oh, mistake than you thought it was. Yeah, yeah.
Whoopsies.
And then we can make it, I guess you can pull the 2 up top.
And you get
2x plus 3, right?
Yeah.
Oh, that's nice. Because the 2 pulls up and distributes, and then I have over rad 19. That's a little bit better, but let's just call it quits while we're ahead. Sound good? Why? Why was it so complicated? Why was there a U and a V? Why did we have to split it up?
it's been the big chunky.
Yeah. This x plus 5 did not perfectly work with our du. It's still off by a constant. I just needed to go ahead and split 5 up into the piece I needed and the piece I didn't. Then I split that up into, hey, sweet, he's du. Let's make the entire denominator u. And this one, it's like, oh, well, he's a constant. Oh, I have to go to arctan with u squared plus a squared. Does that make sense?
Yeah. Is it a good thing to, like, if you have a process for integrating, just be like, first thing you do, always pull up constants?
Typically. Typically. Alright, section 7.3. But to introduce section 7.3, section 7.3 allows us to deal with tricky integrals. We're going to introduce by talking about some integrals that don't need parts. What? Let's talk about some tricky ones that we can do. In my old book last year, there was actually a whole section just on, hey, guess what? You know how to integrate? That's great. Let's go to tricky ones that you don't think you can integrate, but you can.
Did you know our ACT results class of 2016 average was 23.8?
Is that good?
No. Well, it's above the average, but.
What's the max score of an ACT? I never took that one.
32.
Oh,
Or
32.
36, my bad.
You know, all I ever hear at this school is above the average.
We are. Then we also have a smaller sample size. So we have to go for some error. Did we do any of that, Mr. Holloway? No.
This just got kind of intense real fast.
Yeah, Mr. Holloway, we didn't do that.
dog on Mr. Holiday.
Especially since we're recording right now.
Oh, shoot. Sorry, Joyce, we're deleting the video.
If we're deleting the video, she wouldn't hear it.
That's true. I'll tell her, just delete this video and I'll tell her later. Okay, Steve?
Oh, Lord.
Butter?
No.
Should be.
I was just trying to make fun of in Mice and Men. They said the way they say God was God, Gawd.
Okay.
So dog.
I think I'm tracking, but I'm just gonna stop the line of thought. Okay. How can you solve the first one?
Unfortunately. Can you do upside down hard?
Even with the disguise for a vlog with it.
Oh.
That still did nothing for me.
Wait a minute. Oh, I know what you do. You can do no.
You made
Yes.
Satan you.
No, you can do to the -1 and then do u equals 1 plus e to the x.
Wait, why can't we make u 1 plus e to the x?
Let's try it. What happens if we do?
Something-
There's an e to the x.
Yeah, you're right.
What would you equal?
E to the x. And then we have the 1 over e to the x, and then we get.
Ready?
What?
Steve did magic. Ha He did integration on crack.
Yay.
That was better than crack.
We're recording today.
Still recording.
Okay.
Wait a minute, but what do you do?
It would be 1 over 0.
No.
Indeterminate.
What? It's 1 over u squared minus u, right?
Yeah.
Yeah.
How is it u squared minus u if it's JK? No, yeah, because it's u times u to the -1, so u to the 1, so
What do you mean
plus.
times u to the -1? They're both u to the -1 technically if you want to go that way. It's just u squared though.
No. Oh wait. Wait, no.
Yes, it works. Just keep going, Miss T.
Wait.
I need to listen to that video because I have no idea what just happened.
Neither do I. That's so funny.
Should we do that?
Oh no.
Why'd you complete the spread? Why'd you complete the spread?
How else would
Because
we do
now,
it?
Well, can't you? Maybe I'm killing a puppy. You have u squared minus
It should be 2
u. Can't you flip it up to make it u squared? Oh well, then we can make it v. U squared minus u equals v, and then we have 1 over v
and it'll end up being the same.
dv,
No,
and then ln.
But then we have 2u minus 1. Where does he come
What
from?
do you get the 2u minus 1?
Well, because you need, when you do v, you need db, right?
Oh yeah, what do you get?
Oh, I'm sorry. I thought
That's
that was
not
a
1/2, Jackie's right. Hold on. I didn't complete the square right. What should it be?
That was u to the -1.
Plus 1/4, right?
That was u to the -1. I'm sorry, Miss D. I thought that was a u to the -1. You're right, George. I am smart.
I didn't say you were smart.
How are we doing?
Calculator.
Question.
Answer.
Why are we stuck?
Because we need to do integration by parts.
Because
No, we don't.
Oh.
We're good now.
We're good.
Why?
we have here.
Because it's our
Oh,
trick.
Is it?
tangent.
Arctangent.
Is it?
Yeah.
Stop. Yeah.
Is it?
V
Yes!
squared
Is
and
it?
a constant squared, which would be 1/2.
For the love of God, yes, it is.
Isn't it u squared plus 1?
Chemical.
Or u squared plus a squared?
Can it be? Oh no.
Yeah, it can't be a negative.
Yeah, it is a negative. You said it's the
Because a
same as
negative
negative.
squared.
It's u squared plus
Oh,
a
it has to
squared.
be greater than.
No, no, the arc cotangent. You said it's negative.
No,
The
but the
negative
whole
would
thing
be
is
on top.
negative, not just one little baby piece.
If you
I
just
would
said-
need a negative there and a negative there to
So
pull
should
out
I
a
keep
negative.
writing this down, or
Correct
just a
this.
waste of my space?
We're doing great, except completing the square doesn't work because we get a minus. Well then how on earth are we supposed to?
Carefully. my God, Greeners, did you get that? No. You don't mean. Oh God.
Partial fraction.
No.
Dear Lord, no.
Partial.
That was my least favorite section. Of all
Now, the nice
of
thing is hopefully our book actually has a whole section for partial fractions. If not, we're going to have a few issues. But long story short, I'm not going to teach it right now because I think our book covers it in, just wait for it. Just wait for it. Just wait for it.
Wait.
Just, where is it? Where'd you say? Section 7.5. We're going to come back to partial fractions, but for right now, do you want to see how it works?
Yeah.
There's something called a thumb trick,
Oh yeah.
or a hand. As long as you have two factors that are both linear, you cover one and plug in a 0. Ultimately, it's a shortcut to what you would solve. Partial fractions, for those of you that I didn't have for pre-cal, you have to put an A and you have to put a B and you have to go solving for stuff. But the thumb trick lets us make a quick jump and say instead of putting A and B, we can cover U, which has a 0 of 0, and we can plug in. Cover a factor, plug in at 0. So cover U, plug in 0. 1 over 0 minus 1 is negative 1. Oh, sweet. Cover him, who's his 0?
One.
What's 1 over 1?
One.
Why is that so much better?
Because Satan doesn't have to be treated.
This is just going to be negative ln of who? U. Plus, well, you could make a v, right? V is equal to u minus 1, dv is 1, so we're okay, no big deal. Plus ln of u minus 1. Plus c, and of course, hopefully you guys are like, wait a minute, I think there's a property with that. Well, hold on, who is u minus 1? Just e to the x plus c. Oh, wait a minute, ln of u to the x, isn't that just...
Oh, it's x.
Hmm.
Close.
So we could go ahead and simplify that a little bit further. Or we could be super snazzy and we could do something like ln of e to the x over 1 plus e to the x and just use quotient rule instead.
Quotient rule.
Negative. Oh yeah, no.
Because it's this one minus that one, he's on top, he's on bottom. Whew, that was rough!
So are we doing?
But technically it's just done with pre-cal.
Are we doing partial fractions?
They're coming at the end of this chapter.
What?
But partial fractions are technically pre-cal, so I'm just saying, hey, they're a thing and they're going to help us do some integrals that would have been quite difficult otherwise.
Thank God I found my pre-cal notes.
How about a disguised power rule? What?
Huh?
Disguised power
What?
rule. What?
Something times u prime.
Who's u?
Sine of
Cotangent. But wait, du would be negative cosecant squared. U gross. No. Who's u?
Sine of x?
Nope.
ln of sine of x.
Yes. Why?
Because you need
You're always looking for a du that fits. What's the derivative of ln of sine of x?
1 over sine of x times negative cos.
Cotangent.
What? How do you know that?
1 over sine times cosine. Cosine over sine is? Cotangent.
Oh, slow down. Say that again?
1 over sine times cosine.
Oh, because okay.
1 over u times u prime.
Yep.
Which equals cotangent of x dx. This one is really just the integral of u du, which will be 1 half u. Who's u? Exactly.
It all rhymes.
Let's see. Sorry, I didn't solve.
1 over cotangent tangent.
Yes.
So tangent over tangent.
So we could just make a tangent and then tangent cotangent is 1. Now, hold on. Question. Can I bring this nifty 2 down and then cancel because it's an ln? The entire thing squared, not just the sign, right? Keeping it legal. Okay, what about this one? Boop. Oh, just kidding.
Whoa, there, George.
We get it?
No.
Wait, can I put the 2 in front of the ln like trig notation?
No, because it's the whole thing squared.
Iteration.
Wait.
It would have to be ln of sine of x squared, not ln of sine of x.
Well, you said in homework that you could do like ln and then the squared and then the.
Oh, like put a little square here?
Yeah.
Oh, I guess so.
Okay.
I don't think I'll ever do that.
And then
I guess so.
brackets.
How about now?
savages.
Go.
Ooh, boy.
Ooh, wait a minute. You saw one of these in homework-ish last night, right? Use trig identities. What? There is no straight antiderivative from tangent squared. Well, then what do we do? Not u sub, unless you're making u2x.
Sine squared of x over cosine squared of x.
Well, can we use
Good idea, but no.
secant squared x minus 1?
Ooh, that's almost the property.
Oh, hold on.
Wait, no, you're right. That isn't the property.
Oh, it is?
It equals
Because it's 1 plus tangent squared is secant squared. So secant squared minus 1. Why is that so much more helpful?
you can split it up. And secant squared is just tangent.
Exactly. Tangent squared doesn't have a straight antiderivative, but secant squared does. So then I can go ahead and
I'm sorry, you're faster than I am. It takes me a second to get it down. Is that bad?
Something bad about you. The broad board evil according to Mr. Well, so yes, you are.
according to the
Pretty, yeah. Dude,
Okay, so
right.
you are bad. You are though. Miss D said so too.
but not any worse than the rest of us. Just maybe with different manifestations.
Well, I don't know if that makes me feel better.
Maybe with different
Just kidding. I'm
manifestations.
yoking. It's a yoke.
It's a yoke.
It's a yoke.
Spanish 3.
So are you deleting this recording?
This is probably
Wait, was
good.
there anything inappropriate?
What?
No.
Just something
I feel
about
like every-
crack and Mr. Halliday. And,
It's not like he watches this.
well,
But
I
it's-
don't really need,
Jack and crack.
Oh my
Right hand
goodness.
says go, Jordan. No, I did it before it said go.
Last one.
Oh no, wait.
Mm-hmm.
What are you seeing? What would you think of setting?
3x squared plus 6x. And can you do a v equals? I did that in homework.
Oh boy. Here's moving so fast.
Do we need to go that hard though?
Maybe not.
Because the 6. He's not as hard as What did I just say? Pull the 6 out, right?
As a general safety rule, always pull stuff out.
It usually makes things a little bit more clear as to the direction you're supposed to go.
Okay.
Because why? Well, if I plug in right now, I have an x plus 1 all over square root of u times du over 6 times x plus 1. Isn't that nice?
Yes.
6, and x plus 1.
Almost thought it was one of those nasty ones with complete in the
Then
square.
2/3 u to the 3
I don't want to do a complete square.
U to the negative 1 half plus 1. We
3
already went
halves,
there,
and then
right?
you got a 2.
Plus 1?
Ah, dang it, I
Good,
did that
away, sorry,
wrong.
bud. Let's do over 1. It's going to be 1/3 times u. Who's u?
Me. He's beating, I do.
Who's on first?
I don't know.
Exactly.
What are you asking me for? No, it's an actual old.
Abbott and Costello.
Yeah.
Africa Screams. Hilarious.
I love that movie. It was great.
Which one?
Rain Man.
That is a good movie.
The Tom Cruise and some guy I don't know his name.
So wait a minute, these are all ones that we could solve, right?
Kind of.
But did they have little, kinda, did they have little tricks?
Yeah, I got a little trick.
So what on earth do we need parts for? We can do so much.
Parts are for schmucks.
But what about this one?
When do we need
Oh. Well, yeah.
Trig properties. Sign doesn't really do much.
Well,
Partial fractions? We don't have any fractions. U is sine, du is cosine. Make it cosine inverse? No. No, we're not doing integration on crack.
why not? If it would work.
It won't. Because if you make u sine of x, du is cosine of x, go back and solve for x, that'd be sine inverse of u. We're not going there.
Right.
So we have to go back to the product rule and say, wait a minute, are we missing something? Okay, product rule. Derivatives, right?
Right.
You do a first t second. You could do first t second plus second t first, right? But what does that mean? Well, that's the derivative of du dv, right?
I don't. So much.
So what happens if we multiply everything by dx? What do we get?
We get u dv times v du.
Well, you should just get d up front. Right?
So then
And what if we want to integrate
Oh, wow, that makes it like easy.
both sides?
if we want to integrate, then we get
You can't integrate the left, but you can do it. You can do yourself integrating the right.
Well, if everything's in terms of x, though, is it really a problem? I mean, right now we're dealing with notation, but everything's in terms of x, technically. This is just notation. And if we're doing addition, can't we technically split these up to be u dv plus integral of v du? We can split up integrals across addition. What happens over here? If I have the derivative of the product, what happens when the integral is being taken?
It's just a product.
It's just the product. I don't have to put a plus c because I have some plus c's implied in my indefinite integrals over there, right? What does this show me? What's the point? Well, the point is I can take the integral.
Wait, is that first in dv? Right? Yes.
How did you get rid of the on the other side?
This is the derivative of the product rule, so the integral of the derivative, just think FTC. They're inverses of each other. Without going too crazy. You can, if it helps, you can think you're multiplying this dx to the other side, and you're multiplying this dx to the other side, so if you want, you could write it also like this. That'll make it a little bit nicer. Instead of canceling them both out, you multiply this one up and multiply that one over. Then I have little dx's technically, so it's legal. And this one, well, you just, there we go, now we cancel. Guess who was in that big old box that I showed you for section 7.3? This formula. But why is this formula helpful? Because I can look at an integral with seemingly two unrelated pieces, and I can separate how I solve.
Oh, yeah.
I can separate how I solve. And if you notice, what happens to the v when I go to the other side? He is a dv, which means derivative of. If I need to go back to original, isn't there going to be integration involved? So dv, I need to make be the piece that can be integrated. And technically be dv along with the dx. Sorry, I didn't distribute my little dx as I was going. And then what happens to the u as I come over here?
Well, why is it parentheses on the du and the x's?
Because they're both derivatives, so we can think of them as being related. What happens to the u? He gets derived. And here's the long story short of integration by parts. If we can choose a u that gets simpler when it's derived, and a dv that can be integrated, then possibly, with integration by parts, what was impossible to solve is now one step simpler. Still in an integral, and I'll still have to integrate, but possibly by integrating dv and deriving u, I have something that's much more solvable? Ugh. Much more able to be solved. That's even worse. So what if I was, oh, give me 1 second. So what if I was to take the function that we already had, right? And who is that? X sine x. And we're going to learn tomorrow how you can make u into x, v into sine x dx. You guys can back up. This comes from a negative cosine of x when you integrate. This one you derive to get du. And then we do something I call lucky 7 to say, hey, this integral is going to end up equaling uv minus the integral of v, which is going to be a negative cosine of x dx. If that's all I have to solve, I got it.
That's the integral of u dv dx?
That's the integral of.
Oh.
Alright, cool kids, get out of here. I'm going to finish this one and then save it online. Joyce, you're probably tracking, so we'll
I came from Bible.
What?
I came from Bible.
Bible?
Yeah.
From Mr. Shark?
Fine.
Joyce, if you like this video, like, subscribe, leave a comment in the description below.
¿Viste que voy a hacer hoy?
Bye guys.
Did you see what I'm doing today?
I'm going to the